To start recording.
Did you click the mic up?
I think we're good.
I don't know. I don't know what it's doing now. I don't know if it's doing it or not.
Let's just hope. Sometimes it takes little faith.
All right, well, I'm going to do this. I'm not sure if, where's Nick? I don't know if it is. All right, okay. All right, here we go. We're going to do what we did, what I started to do yesterday, that is define a tangent plane to a surface at a point. And to define a tangent plane, to define any plane, we need two pieces of information. We need a normal vector to the plane, and we need a point. Well, we're going to be given the point. What we have to do is find that normal vector. Okay, where do we get the normal vector? We get the normal vector by taking our surface and making it a level surface to a fourth dimensional object, a function of three variables. So, here is our function is 4 minus x squared minus y squared. It's a paraboloid coming down this way. Here it is here. And we're going to take a point, 1, 0, 3. That's our point right here, 1, 0, 3. And what we're going to do is find the normal vector at this point, which will point out this way. And we're going to define the tangent plane to the surface at that point. Okay, so here's our surface. And what we're going to do then is to take W equal 4 minus x squared minus y squared minus z equals 0. Please note, what this is to set W equal to our surface, subtract the z from each side here. This is z equals 4 minus x squared minus y squared. I'm going to set W equal 4 minus x squared minus y squared minus z, subtract the z from each side, set it equal to 0. What that will do is take our surface and make it the level surface to this fourth dimensional object W. That's what this is right here. Notice, when this is equal to 0, we have our surface. Add z to both sides and we get our surface back again. Okay? If we were to set this equal to 1, we would get another level surface to that fourth dimensional object. All right? Okay, next we're going to find the gradient to W, which is the partial of W with respect to x, with respect to y, and with respect to z. It's the natural extension of our definition of a gradient to a function of three variables. A gradient for a function of two variables, partial of z with respect to x, partial of z with respect to y. We extend it out another dimension, we add another component to that gradient. So it's going to be the partial of w with respect to x, w with respect to y, w with respect to z. That's going to be a negative 2x, take the partial with respect to x, negative 2y, take the partial with respect to y, and a negative 1, take the partial with respect to z. That's the gradient. That gradient has the same property that the gradient for a function of two variables has. That is to say, it's going to be normal to the level surface now. The gradient we did yesterday was normal, or the day before, whenever it was normal to the level curve, perpendicular to it, pointing outward. This is normal to our level surface, pointing outward. That's the normal we need for our tangent plane. So, what I've done here is to take this normal vector, and the normal vector came out to be negative 2, 0, negative 1. Okay, when you put in the point 1, 0, 3 was our point, right? 1, 0, 3, yes. So I put in 1, 0, 3. We get this negative 2, 0, negative 1. And I took the negative 1 out and took the opposite of the gradient, okay? Just to make it a little bit easier to do. And I did it by drawing the vector from 103 to 304. In other words, giving me this 201 gradient, okay? All right, here it is here. You can see it here. This is the gradient right here, okay, at that point. And you can see it's pointed outward, and it's going to be normal to this level surface, okay? In addition to that, we've got a point, 103. Okay, here, I did this in general. Here's my partial with respect to x times x minus x sub naught. This is the equation of a plane. Partial with respect to y at y sub naught at that point. Partial with respect to z, -1, at z sub naught. This is the equation of that plane. Recall we did the equation of a plane. At this point, substitute in for x sub naught 1, substitute for y sub naught the 0, and the z sub naught substitute in the 3. And then solve for z, and that's what I did. So after making the substitution here, we get this for our tangent plane. And that's what we're going to, okay, let me do this one first. Okay, that is our gradient, our normal vector, and then this, hey Dan, is our tangent plane, okay? That's the tangent plane that we define by taking that normal vector as our normal vector, and the point, okay? This is the gradient, okay? It's our normal vector, there's the point, and there's the tangent plane we just defined. All right, we're going to generalize now and use a manipulate to change that tangent plane to that surface. We're going to vary this thing, all right? So, let's do just that. Okay. What I've done, I started at the top where the point is, the x is, all right, the x is 0. I just moved it a tad. All right, well, it started 0, 0. That's the top of this. At 0, 0, we're at the point 0, 0, 4, the top of this paraboloid, okay? And now what I'm going to do is move the x coordinate of this. As I move the x coordinate around, that tangent plane is going to move down that way. And if I make x negative, it's going to move down the other side. And I can do the same for y. Move the y and then move it down this way. Okay? And then I can animate these guys. I can set the x going on its own and the y going on its own. So this thing will travel around that surface.
So
And
basically we have this crazy shape.
yes.
We find the tangent surface, and then we find the vector normal to that surface.
Not quite. I don't quite like the way you said that, Teddy. Here's the deal. Okay, we start. What's that? Wait, we start with the surface
Right.
and a point. We find the normal vector,
Which is
Oh, okay. So
okay, which is the gradient
go right
to the
up,
fourth
right,
dimensional
gradient.
object. Then we define the tangent plane to that surface at that point.
which is
Okay?
So you find. All right. So that normal vector is the gradient.
That normal vector is the gradient for our fourth dimensional object.
and that paraboloid or whatever you want to call it is
That's our surface.
that's our fourth dimensional object.
No. Oh, it's a level surface to the fourth dimensional object. Yes. It's a level surface to the fourth dimensional
Don't
object.
make assumptions here.
Oh,
All right, hold on. Let me do this. Let me do this. Hold on. I'm going to go back to the document camera. Okay. I'm going to see if this actually recorded anything I just did. I kind of doubt it, but I don't know. Let's see.
God forbid.
Hold on a second. I got my dot. So I think